So when we're talking about Pythagorean theorem, sometimes we talk about the converse of the Pythagorean theorem. And we discuss basically if you're given three sides, can we figure out if this truly is a right triangle? Instead of being given two sides and then using the fact that it's a right triangle to find the missing third side. So first of all, we have three different types of triangles. We have right triangles, you have acute triangles, and you have obtuse triangles. So if c squared is equal to a squared plus b squared, then my triangle is right. If c squared is less than a squared plus b squared, then my triangle is acute. And if c squared is greater than a squared plus b squared, then my triangle is going to be obtuse. Always keep c squared on the left side to avoid confusion when you're classifying a triangle. So that's important to remember. So I'm going to highlight that. Another important thing to remember is that you first need to determine if the three side lengths actually could form a triangle. So we need to do that by determining if the sum of the two smaller sides has to be greater than the third side. And if that's not true, then it is not a triangle, and we don't even have to go any further. So we're going to start with number 1. So we have 3, 7, and 9. So the first thing we're going to do is determine whether or not this actually is a triangle. So I'm going to add the two smaller sides together, 3 plus 7, and I'm going to compare it to the number 9. So 3 plus 7 is 10, and 10 is greater than 9, so this is okay, because we got to make sure that the sum of the two smaller sides has to always be greater than the third side, or it can't be a triangle. So number 1 is a triangle because that is a true statement. So now we need to figure out the squares. So we're going to start with the largest number. That's always going to be my c squared. So that would be 9 squared. And then I'm going to compare that to 3 squared plus 7 squared, or the sum of the two smaller sides. So 9 squared is 81, and 3 squared is 9 plus 49. And when I add 9 and 49 together, I get 58. And in this case, 81 is greater than 58. And if we go back to our notes, if you have greater than, that means we're going to have an obtuse triangle. So now I want you to try number 2. So the first thing that you need to determine is if it really is a triangle. So you're going to take the two smaller sides and add them together. So that's 20 and 21. And then you're going to compare that to the largest side, which is 29. And if you add 20 and 21 together, you get 41. And 41 really is greater than 29. So that means this is a triangle. So now you're going to use the Pythagorean theorem. Remember, you always start with your biggest number first. So that would be 29. And you're going to do 29 squared. And you're going to compare that to the sum of the square of the two smaller sides. So that's 20 squared plus 21 squared. Number 3, first things first, determine whether or not this is a triangle. So I'm going to do 4 plus 11, because those are my two smaller sides, and I'm going to compare that to 16. 4 plus 11 is 15, and when I compare 15 to 16, it's less than. Remember, it has to be greater than, and so in this case, this is not even a triangle. So we don't even have to go any further and do any squaring. Number 4, same thing. We're going to add the two smaller sides together, and we're going to compare those to the largest side. 17 plus 17 is 34, and 34 is greater than 22, so this is a triangle. So now we're going to use Pythagorean theorem, and remember, use your largest number first, so that'd be 22. So I'm going to compare 22 squared, and I'm going to compare that to 17 squared plus 17 squared. And I'm going to figure out if it's greater than, which would make it obtuse, less than, acute, or equal to, which means a right triangle. On number 5, first of all, let's see if it's a triangle. 18 plus 24. So we're going to add our two smaller sides and compare them to the largest side, which is 30. 18 plus 24 is 42, and 42 is greater than 30, so this is a triangle. So therefore, I can use my Pythagorean theorem. So I'm going to start with my largest side, which is 30 squared, and I'm going to compare that to the two smaller sides squared, which is 18 squared and 24 squared, and I'm going to find the sum of that. And then when I figure out if it's greater than, it's obtuse, less than, acute, equal to would make it a right triangle. Then we're going to do number 6. First of all, we need to figure out if it's a triangle, so we add the two smaller sides together, and we compare that to the largest. So if we add 18 and 15 together, we get 23. And when you compare 23 to 23, they are equal. But equal is not good enough. It has to be greater than. So therefore, this is not a triangle. Number 7. First things first, check to see if it's a triangle. So 31 plus 35. And we're going to compare that to 39. And this gives you 66, which is indeed greater than 39. So this is a triangle. So then you need to go on and check to see if it's acute, right, or obtuse. And then I'm going to let you work number 8 together on your own. Remember, check first if it is a triangle. If it is a triangle and the two smaller sides are greater than the larger side, then you can go on and check to see if it's acute, obtuse, or right. Thank you.